Let's see the properties here. See, previously we said that is A into A inverse equal to A inverse into A equal to identity matrix. And one more, A inverse whole inverse equals to always is going to be A. That is, after finding inverse of matrix, if you find once again inverse, you will get same matrix. A inverse whole inverse equals to A. And AB whole inverse equals to, we have to write B inverse into A inverse. Like AB whole transpose equals to B transpose A transpose here, AB whole inverse equal to B inverse into A inverse. Sometimes he will give like this also, ABC whole inverse equals to, here AB whole inverse ante B into B inverse C in A inverse. ABC whole inverse is nothing but C inverse into B inverse into A inverse. This is asked in ECET. ABC whole inverse equals to A inverse, B inverse, C inverse ichinaru. C inverse, B inverse, A inverse ichinaru. Which one is going to be right? That is C inverse into B inverse into A inverse is going to be right one. Right? Same thing. One more very important, that is A into argent of A or argent of A into A always is going to be determinant of A into I. If you multiply one matrix with adjoint matrix, you will get determinant of A into I, you will get. It is also one matrix, right? A determinant of A is nothing but number. Identity matrix is nothing but 1 0 0 1 0 1 0 0 0 1 0 0 0 1. That in place of 1 you are going to get determinant of A. See, one more I am giving here. That is, from here only A inverse formula is created. If I take A inverse this side, A this side it's going to be A inverse. That is 1 by determinant of A into argent of A. That what I am saying means, indirectly A into argent of A equal to determinant of A into I. If I take A this side, it's going to be A inverse. If I take determinant this side, multiplication 1 by determinant of A into argent, I am saying. From this formula only you got this formula. That's very important, the basic one in inverse, that is A into argent of A equal to argent of A into A equal to always determinant of A into A. Any manner, if you multiply A with argent or argent with A, always you are going to get determinant of A into I. Same thing here, inverse matrix determinant equals to 1 by determinant of A. If you know determinant of A, we can say inverse. Without finding inverse matrix, we can say determinant of that matrix. And here, Ka inverse, not determinant. Ka inverse equals to 1 by K into A inverse. Nothing is there here. Simply Ka, when for suppose 2 into 3 whole power minus 1 is there. We'll write 2 power minus 1 into 3 power minus 1. Here also same. Ka whole inverse is nothing but K power minus 1 into A power minus 1. K power minus 1 is nothing but 1 by K into A inverse. No need to separately remember this. Simply, Ka whole inverse equal to matrix inverse. Inverse matrix is nothing but what? This one, by using this formula. Steps already we given steps. Inverse means first of all you have to find determinant. If determinant of A equal to 0, then it is not going to be, we are not going to have inverse matrix. That's why I given non-singular matrix. If A is non-singular matrix, then only inverse is going to be existed. In first step again, if determinant of A not equal to 0, then we will process. If determinant equal to 0, it is singular matrix. We can't find inverse matrix. Why? Because 1 by determinant is there. Same thing, one more very important, that is Ka whole inverse determinant equal to, from here only 1 by K power n into determinant of A. Always determinant is number, it is also number. 1 by K, actually here we know one formula is there, that is what? Ka determinant equal to k power n into determinant of A. That is 1 by A determinant, inside is there determinant లో బయటకు వచ్చినప్పుడు 1 by k power n is going to be inverse matrix determinant is equal to 1 by determinant of A. Simple and sweet. If you remember these values, right, this is very important. From here you are going to get from these all properties already is the basic ones. Just I am going to give you an example to divide this one. Based upon these properties you are going to get in a problems here, right? I am writing one problem here, that is if A into argent of A equals to A into argent of A equal to 500500005, then determinant of A equals to what? He will give this question. He will ask what is determinant of A. Either you can ask what is determinant of A inverse. Either you can ask determinant of 3A whole inverse determinant. He may ask this like type of questions here. Any one question you may ask. So 3 is nothing but you will get confused. I will write 2. You won't get confused. Here see, this is 3 by 3 matrix. Means indirectly A is going to be 3 by 3 and argent is going to be also 3 by 3 matrix. He will give this matrix. He will buy. This is the condition and is asking anyone he can ask. I am saying 3 values. Let's see what he given this matrix. Means indirectly we know from A into argent of A equals what? Determinant of A into I. But actually to this do this problem you will get confused, but without confusion, if you use this property you will get an answer. You see, if you asking what determinant of A means, without knowing A how can find determinant, you will get a doubt. Without we didn't have A here, how to find A inverse? After finding A inverse, then only we can find determinant. How to find A determinant of A inverse? And also here 2A inverse. We don't know A. How you will get 2A? Without getting 2A, how you will get 2A whole inverse? After getting 2A whole inverse, you can find determinant. But it's simple answer. If you know determinant here, we can say these are all determinants here. If you know determinant of A, that is A into argent of A equals to one matrix. A into argent of A equal to determinant of A into I. If this is A matrix, here identity matrix is nothing but 1 0 0 0 1 0 0 0 1. Simply it is going to be determinant of here I will write, don't worry. Determinant of A 0 0 0, determinant of A 0 0 0 in determinant of A. Like this is going to be, you have to write like this, but we don't know the order. That's why we are writing in a property. Right? In place of determinant, what we have 5. That's he written what? Just you taken determinant of A outside, simply written I. See, in place of determinant from here, from this question, now we can say determinant of A equal to 5. Now first answer is over. If you know determinant of A, we can say inverse matrix determinant, that is going to be 1 by determinant of A, that is going to be 1 by 5. If you know determinant of A, we can say that is Ka whole inverse determinant, that 1 by k power n into from here, that is 2A whole inverse determinant equal to 1 by 2 power n equal to 3. What is here? N means order. Here the matrix order is going to be 3, that is 2 cube into determinant of A, that is nothing but 5. 2 cube equal to 8. 8 5 is what? 41 by 40. If you know determinant, we can say this many answers. That is also logically given. Sometimes here the given condition. For suppose if he given A matrix, if A equal to, he given A, finding A inverse by using our shortcut, very easily we can get. With small representation, simply by using our trick, determinant trick, by using that trick, we can find determinant of matrix. After finding determinant, we can say any value here once again. But that is also very easily given. That is simply that. అండర్స్టాండింగ్ మై పాయింట్. ఇయర్ 3 ఉన్నాయి కానీ 3 5 into 5 into 5 కాదు, ఇండైరెక్ట్లీ ఓన్లీ 1 5, దట్ ఈస్ ఇన్ ప్లేస్ ఆఫ్ డిటర్మినెంట్ వీ హ్యావింగ్ ఓన్లీ 5. Understanding my point? Nothing is there. The properties are going to be represented like this. These are the properties, right? Actually, more properties are there. We'll write other properties also after this. Okay, right? Let's see other properties. Just whatever just I discussed, I given the properties. Based upon that, I just given one example here. Like these problems you are going to get. You have to treat this as a question. So many times asked in ECET. Okay, in ECET you got this type of questions here. This not only 5 ane kaakunda 3 ravachu, 4 ravachu, any number you can get. Just I taken 5, that based upon that I given, right? And more properties we'll see. What are the other rest of properties we'll see. Let's see other properties. Let's see more properties here. Argent of A transpose means indirectly, if A is given, you have to find A transpose first, then after you have to find argent from transpose. Either you can find like this also, argent of A whole transpose is also going to be argent of A transpose, and after finding argent, if you transpose also, both are going to be equal. And one more, argent of AB equals to argent of B into argent of A. To find the argent of AB matrix, AB is one matrix. If you know argent B, argent A, if you multiply those two, like this, argent of B into argent of A, not argent of A into argent of B, then you will get argent of AB. For suppose argent of KA equals to K power n minus 1 into argent of A. Here K is nothing but order, n is nothing but n is order of matrix. N is nothing but order of matrix. For suppose if A is 3 by 3 matrix, you will get K square, you will get. Right, same thing. Here one more very important, that is argent of A whole inverse equals to 1 by determinant of A into A. This is also very easy, nothing but A into argent of A equals to determinant of A into I. If I take in A this side, you got A inverse formula, that is nothing but A inverse equal to 1 by determinant of A into argent of A. For suppose if I take argent of A this side, once again you will get determinant this side, 1 by determinant of A into I equal to this side I into argent of A whole inverse, nothing but argent of A whole inverse only na. This is indirectly proof, but it is also by using our property only, that is A into argent of A only. A inverse formula also from there, argent of A whole inverse also from there. He will give the problems based upon this. If he asking, if by giving A, if he asked argent of A whole inverse means you have to find argent. Argent means you have to find each and every element cofactor. Cofactor means you have to find minors. It will take more time by finding minors, and after that cofactors, by replacing cofactor, after that transposing a cofactor matrix, you will get argent. After that also argent of A inverse is nothing but means, for suppose what is our formula, A inverse 1 by determinant of A into argent A. For suppose if we write argent of A whole inverse by using inverse formula, in place of A you have to replace argent matrix, determinant of argent into argent of argent. Just I replaced A with argent matrix. A place la argent rasna. With that you got this formula. This is actually A inverse argent of A whole inverse formula, but no need of doing this one. Simply A by determinant of A చేస్తే ఆన్సర్ వస్తుంది. ఇక్కడ అర్జెంట్ ఫైండ్ అవుట్ చేసి దాని డిటర్మినెంట్ ఫైండ్ అవుట్ చేయాలి, మళ్ళీ అర్జెంట్ మ్యాట్రిక్స్ అర్జెంట్ ఫైండ్ అవుట్ చేయాలి. వచ్చిన మ్యాట్రిక్స్ను ఈ డిటర్మినెంట్ని అర్జెంట్ డిటర్మినెంట్తో డివైడ్ చేస్తే వచ్చే లెట్ లాస్ట్ అర్జెంట్ ఆఫ్ ఏ యూనివర్స్. నోట్ ఆఫ్ దిస్ ఆల్ ప్రాసెస్ సింప్లీ ఇఫ్ యూ ఫైండ్ డిటర్మినెంట్ మ్యాట్రిక్స్, ఇఫ్ యూ డివైడ్ విత్ each and every element of A, then you will get argent of A whole inverse. And one more very important that if A is a n by n matrix, then determinant of argent of A equals to determinant of argent of A equals what? That is going to be simply determinant of A whole power n minus 1. Have you got means? Very easy. That is A into argent of A equal to we given, that is determinant of A into I. I am taking both side determinant, that is going to be determinant of A into argent of A equals to determinant of A into I. Determinant of AB formula, determinant of AB is what? Determinant of AB equal to determinant of A into determinant of B. From there this is A, this is B, that is determinant of A into determinant of argent of A. Determinant of Ka equal to K power n into determinant of A. You know the formula, determinant properties. Here this is number, always determinant is going to be number. Here order also given, that is n, that is determinant of A whole power n into determinant of I. Determinant of I is nothing but what? 1. Here I want argent matrix determinant, that is nothing but determinant of A whole power n divided by determinant of A into 1. Why? Because determinant of I is going to be 1. Here 1 is there, that's why you got determinant of A whole power n minus 1. That answer is going to be determinant of A whole power n minus 1. For suppose he given if A is going to be, if A is a 3 by 3 matrix, then argent of A is going to be what? Determinant of A whole square. Simply determinant of A whole square only. It is 4 by 4, determinant of A whole to the power of 4. If it is 5 by 5, he will give the questions based upon this. Simply if A is a 4 by 4 matrix and determinant of A equal to 2, then argent of A determinant equals to what? Argent of A determinant is going to be what? Simply argent of A determinant by using this, if it is 4 by 4, it's going to be determinant of A whole cube, that is nothing but 2 to the power of 3, that is nothing but 8. He will give determinant like previous problem, whatever just we give an example, that is A into argent of A equal to 500050005, then determinant of A అడిగిండు. ఇప్పుడు determinant of argent of A అడిగిండు. Determinant of A ఏంటిది? Here determinant of A equal to 5. Then from here argent of A, if you know the order, here what is the order? A order is going to be 3 by 3 only, that is nothing but determinant of A whole square, that is nothing but 5 square is nothing but 25. See here argent of A whole inverse అడిగిండు. అట్లనే ఇక్కడ మనకు one more we can write, that is argent of A whole inverse determinant. That is only na, simply this determinant na, or we know what? Determinant of A inverse equals to what? 1 by determinant of A. Same thing, in place of A we having argent, we can write 1 by argent of A determinant. Argent of A determinant. Argent of A determinant is what? 1 by determinant of A whole power n minus 1. For suppose if it is 3 by 3, here argent of A whole inverse determinant, argent of A whole inverse determinant ఏమైతుంది 1 by argent A determinant 25, indirectly 1 by 25 is going to be your answer. Or simply 5 square you will write 3 by 3 matrix కాబట్టి. అంటే if you know determinants like this, we can say these are the properties very important you have to learn, you have to remember. Based upon these questions, by seeing you can see the answer if you know the properties. Here see, if you know this one, simply that is 2 cube, that is nothing but 8. This is 4 by 4, 5 by 5 it's 25 by 25 రావచ్చు, nothing but the answer is going to be existed. 7 by 7 రావచ్చు, 6 by 6, any order you can ask. If you know the properties you can say. But if you are representing means you will represent up to 3 by 3 only. In our syllabus we having up to 3 by 3 only based upon that. But if you remember why I am giving this like proofs means if you can remember this one very easily, that's why giving here also I giving here determinant of argent of a proof. Why? Because you are going to remember that one very easily. Without, if you are not remember also, if you follow the procedure you are going to get. But in each and every case, here very important one, that property is whatever just we said, that is fourth property. A into argent of A always is going to be determinant of A into I only. Whatever the properties we discussed here, those are all belongs to that one. Sometimes you may get these properties clearly, but if he is giving that property means based upon that property we can create more. Understanding my point? Whatever just you know the properties, based upon that also you may ask the questions, and interlinking to that also you may ask the questions, right? Follow the properties compulsory. You have to learn these properties, very important. That is A inverse, O inverse. If you do 1 or 2 times inverse, you will get same matrix. If you do 3 times, you are going to get inverse matrix. If you do 25 times, you are going to get inverse matrix. Like that, statements are going to be asked. A inverse whole inverse equal to A, AB whole inverse equal to B inverse into A inverse, ABC whole inverse equal to C inverse into B inverse into A inverse. Like that you have to remember and also asked. But you must and shouldly have to remember that is A inverse is not going to be 1 by A. We can't write matrix in denominator. So 2 power minus 1 is nothing but 1 by 2. It is number, but it is a matrix. We can't write in denominator. That's why if you are taking this A this side or adjoint of A this side, we are writing a adjoint of A whole inverse, but 1 by we are not writing. If you take this A in this side, we are writing A inverse. A power minus 2 we won't get. Okay, always power minus 1, that is going to be inverse of matrix. We named that inverse as we are denoting with A power minus 1. Understanding my point, right? You have to remember these properties and we will see problem based upon this inverse matrix. Okay,